Hi everyone, I thought it would help if I went through the entirety of your practice final exam in case you had questions that you didn't have time to ask during class. So here it is. I'll go through question by question, discussing each one and showing equations that you might use for the mathematical ones. Question 1, which quantity is a vector? Well, that would be weight. The trick here is that weight is also known as the force of gravity. All forces are vectors. Power and energy are scalars. Speed is also a scalar. Number 2, a 65-kilogram astronaut is on the Earth. The question says, what is his mass if he goes to the moon? I'm not reading all the numerical information because mass does not change no matter where we go in the universe. The force of gravity, aka your weight, does. If he's 65 kilograms on Earth, he's 65 kilograms on the moon. Number 3, when the sum of all forces on a block on an inclined plane is zero, the block, well, in any condition, when forces sum to zero, that means we don't have acceleration. An object could be at rest or it can be moving at constant velocity. So based on our answer choices, maybe moving at constant speed is our only choice. Must be at rest, well, it could be at rest, doesn't have to be. It could be constant velocity, so the words must and may have relevance here. Choice 4 is what we want. Number 4, the greatest increase of inertia of an object. Well, inertia is analogous to mass, so we're looking for the greatest mass. Choice 1 describes increasing mass. That will increase inertia. Number 5, a 100-kilogram cart accelerates at half a meter per second west as a horse exerts a force of 60 newtons west on the cart. What is the magnitude of the force the cart exerts on the horse? There's superfluous information in this question. If the horse exerts 60 newtons on the cart will exert 60 newtons back on the horse. This is Newton's third law. 60 newtons is your answer. Number 6, sound waves are, well, this is just a definition question. Sound waves are longitudinal, meaning they vibrate the medium of the air in the parallel direction as their propagation. And they are also that they're mechanical and longitudinal. Mechanical because they travel through air in the first place, longitudinal because they are moving the air parallel to their propagation. Number 7, we have an electrical force of so many newtons between two charges. We double the charges. The new electrostatic force will be. Well, your electrostatic force equation is related to distance by the inverse square law. The full equation is kqq over r squared. But if we double the distance, then we inverse square the force. That would be 1/4. Or I'm sorry, double the distance, meaning we are 1/4ing the force. Because the 2 itself is becoming squared on the right side. So we're looking for an answer that is 1/4 the old force. If we have 8, we're looking for 2 times 10 to the 5th newtons. Question 8, the blue lab cart is traveling to the west on a track. When it collides, it sticks to a red lab cart traveling east. We have the momenta of each object before the collision, and our question is, what's the total momentum after the collision? Well, we have a value of 2 and a value of 3 for individual values of initial momentum, but one cart is going to the west, the other one is going east. So putting all the information together, we would call the 3 kilogram meters per second positive and the 2 kilogram meters per second negative for the initial values of each momentum. That's a total of 1, and momentum is conserved. So after the collision, the momentum total is still 1. Choice 1. We have a diagram of a partial parabola. Object was thrown at an angle, which best represents the friction that acts on the ball at point P. Friction will always act in the opposite direction of motion. So the direction of motion at point P would be represented by choice 1, which means friction will be choice 2. Motion is analogous to velocity. And even though we never deal with air friction in our kinematics equations, in reality it's still there. You'll still follow that property of friction, which is that it always acts in the direction against velocity. A magnetic field would be produced by a beam of, well, this isn't a fair question because it's about magnetism, although magnetic field is produced by moving electric charge. So that would be protons, but a question like number 10 would be one you would not be responsible for on our final. I'm going to make one video for each page, so you can check out the next one for the next page of answers.